of CRC check. Along with that, we'll just see regarding some of the mechanisms of Hamming code error detection and correction. So today, the basic thing regarding the CRC or whatever might be the error detection and correction mechanisms that takes place in data link layer, the major motive is that the message should not be encrypted to someone else. So it means that the message should be protected and delivered or dispatched to the current receiver that who is going to open up the particular message. So message should have a momentum between the sender and the receiver. So no middleman should have the access of this particular message. So if any middleman access this particular message, it should be in a decrypted format. There is no any sort of interruptions that takes place in this particular message delivery is concerned. So the major motive is this as far as the data link layer services are concerned. So now what we are trying to see is that we are trying to send a message between the sender and the receiver so that the receiver is going to receive the message. Between the sender and the receiver, we are going to send the message. So let me just go ahead with basic steps of CRC, and then we'll see the basic analogy of triple R with this CRC check mechanism. So let us just consider the message as 1101. And now this message has to be sent between the sender and the receiver. So what does it mean is that when we go out from our home, we'll just lock our room so that no one will open the door. So the same mechanism is going to take place in the CRC search. So let us just have the analogy. Let us just have RAM and Beam. So now RAM wants to send a message to Beam so that this message should not be. So we'll just have the conclusion of triple R, then we'll see that. So let us just hope RAM have some sort of weapons with him. So he need to send these weapons to Beam so that the message regarding the weapons will not be disclosed to any of the soldiers. And this is the message that RAM wants to send to Beam. So if there are any sort of errors that takes place in this particular message, the details of the weapons will be corrupted or interrupted. So that is the main synergy that takes place when there is any sort of interruptions. So now what happens is that when there are sort of weapons, so this message is to be encrypted and it should be sent to Beam. And if there are any errors, that should be corrected and detected according to the circumstances. Let us just see. So now ROM wants to send a message called as 1101 to Beam. So let us just consider this message have a seal or lock. So the lock is 101. So 1101 is the message and 101 is the lock. So now ROM wants to send this particular message to Beam so that the message will be received by the Beam. Accordingly, it is going to act the circumstances. Now what happens? ROM is going to encrypt this with the help of the message 1101. So this message has a degree of 3. So now ROM is going to add 3 zeros to this particular message. Now he is going to multiply this particular message with that particular key so that there is some sort of reminder that takes place in this particular message. So that is the thing that happens. 101, it is going to add some sort of zeros, and based on the zeros, we are going to get one sort of reminder. So this operation, this entire operation will take place in the form of XOR format. We are doing the XOR operation in this particular format. And suppose let's just consider 101. If we add 1, we get 101 over here. So now 10 is 1, 01 is 1. Now another one is we are going to take down. Now another one is added. Like that, we'll get some sort of reminder. And this reminder will be added to that particular message. So that takes place as far as our code word is concerned. So now we need to create the code word with this particular reminder. So now the code word is created. 11 0 11 0 1. So this 0 1 is the remainder that is added to that particular code word. 11 0 11 is the code word. Now we are adding 0 1 1 0 1 to that particular code. So now if the decryptor or any sort of soldiers that interrupt this particular message, now this message will be interrupted, will be corrupted. So the transmission, there will be some sort of noise that takes place. So let us just hope this noise was created by some sort of soldiers by changing or tampering the messages or the numbers. So this code word should be delivered to Beam. So that Beam is going to decrypt this particular message. If there are any sort of errors that occurred, he just predicts that the soldiers have manipulated the particular message. So now by adding some sort of zeros, we'll be getting the ultimate reminder. Now this reminder is added to the particular message and that message is sent to Beam. Now Beam need to decrypt with the same key. So let us just hope 101 is the key. So this is the same key that is sent by RAM to Beam. Now Beam need to decrypt with this particular message. So then only he can open up the message. RAM has one particular key and Beam has one particular key. We call it as a divisor. We are going to divide the message with this particular divisor. And if we get the remainder as 0, then there are no sort of errors. If the remainder is not 0 or non-zero, any sort of elements, then he can predict that there is some sort of error that occurs in a particular message. So the overall scenario happens with the XOR operation that takes place, the computation that takes place with the XOR operations. So these are some sort of errors that might take place in the transmission of the medium. So now the Beam receiver, he need to check the message. So if the message which does not consist of any sort of zeros, then he's going to say that message is okay. So if there are any sort of zeros that occur during the decryption, then he can say that the seal has broken and there are some sort of decryption that takes place in the messages. So the message that was sent by RAM should reach to Beam without any manipulations or without any sort of errors. If there are any sort of errors that occur while the message or the code word that's sent by RAM, while decrypting the message, when Beam decrypts the message, when there are any sort of code words or any sort of issues that occur, that will be suggested as the sort of decryption that takes place. So the message that was the code word that was sent by RAM, it should be decrypted only with the Beam, with any sort of noise or any sort of decryption that takes place during the transmission. So for this, what we are trying to do, we are trying to divide the same code with the same language. So this message, it is going to decrypt with the help of the keys. So this same key was given to RAM and the same key was given to me. Both of them have the same thing. So with the same keys, they are going to decrypt with the help of the divisors. So this Beam, while decrypting the message, when he gets the error as 0, then there are some sort of issues that occur in the particular program is concerned, particular message transmission is concerned. During the transmission, there might be some sort of errors. If there are any non-zero elements that occurs, then he can predict that there are some sort of errors that occur during the transmission. If the message that is decrypted, it does not consist of any sort of zeros, it consists of some sort of zeros, then he can say that the remainder which consists of zeros, he can say that there are no sort of errors. So this is the overall transmission that takes place while sending the message. So now this message was decrypted, we'll get the remainder. He is going to add the remainder and sending the code word. So that this is the code word that he get after adding the remainder. So this is the code word that is generated after adding the remainder. So this code word was sent to Beam. Now Beam is going to decrypt this code word along with the original word 101. So 101, it is subdivided with 11 0 11 0 1. Now, if the remainder after doing the XOR operation, is 0, then it is going to suggest that there are some sort of errors. If the remainder is, there are no sort of errors. If the remainder is non-zero like 1 or 1, 0, then it consists of some sort of errors that takes place. So this is like going to act as a key to encrypt and decrypt. Now, let us just see one of the other important strategy, that is the Hamming code error detection with the same sort of mechanism. I think it is visible, right? So, Hamming code error detection, it consists of a small rule, that is we are going to have some power of R, which should be greater than or equal to M plus N plus R. This is the form. So this R, it is going to suggest the redundant bits that takes place. So now the M is nothing but the message that we need to transmit. So before we look ahead regarding the practical impartation, we'll just see the theoretical part and then we'll go ahead with the practical impartation of this particular synergy. So now what I'm trying to do, I need to find the R, redundancies. So before that, I need to know the message. So let us just consider message as 1011. So this is the message I need to transmit from the sender to the receiver. So this message need to get transmitted from the sender to the receiver without any sort of manipulations that takes place in the medium. So now 1011 is the particular message. Now what I am trying to do, I am trying to add some redundant bits to this particular message so that the message will be encrypted and it can be decrypted only the sort of receiver. So how many bits I need to add? That should be taken place. So let us just consider R is equal to 1. So 2 power 1 is 2. It should be greater than or equal to. M is 4 bits. 4 plus 2 plus 1. How many bits? 8. So 4 plus 2, 6 plus 1, 7. So it's not right. So now let us just take R is equal to 2. So 2 is greater than or equal to 4 plus 2 plus 1. Means R is equal to 1, right? So 4 plus 1 plus 1. 4 plus 1, 5 plus 1, 6. So when R is equal to 1, we'll get 6 value over here. When R is equal to 2, we'll get 4 plus 2, 6 plus 1, 7 over here. So it is also not right. When R is equal to 3, let us just take R is equal to 3. So 2 square is 4, right? So 4 greater than or equal to 4 plus 2 plus 1, 7. It is not right. So now R is equal to 3. So 8. We'll get the value as 8. Greater than or equal to. So 4 plus how many bits? 3 plus 1. That is equal to 8. So how many bits we have? 4 plus 3 plus 1. 8 bits we have. So while taking this 8 bits, we'll be having 8 bits. So now we get the value as R is equal to 3 bits, right? So R is equal to 3 bits. I'm going to get. So when R is equal to 3 bits, I need to take 3 bits to add this particular parity. So the particular message is 1011. I need to add 3 parity bits. 3 parity bits to this particular message. So let us just consider the bits as R1, R2, and R3. So now I need to take the values as R1. What values I need to take? I need to take the randomized values, which consists of 2's. So which is going to have the manipulations of 2 power 0, 2 power 1, 2 power 2, and so on. So now I am going to take the bits as 2. So this value should be replaced with 2. So what are the positions? 1, 3, 5, 7, etc. R2, what are the positions? 2, 3, 4, 5, etc. Sorry, I mean 2 bits gap. 2, 3, 6, 7, etc. Now what is R3? I need to go ahead with the 4 bits. 4, 5, 6, 7, etc. Or what I need to do? I need to write the particular message regarding all the bits, starting from 1 to 10, 1 to 7. So I'm going to add 3 bits, right? Along with that particular 4 bits. I'm going to add the positions 1, 2, 3, 4, 5, 6, 7. Now I need to add parity bits at which positions? So 1 is parity bit, P1. I'm going to add parity bit P1 here. 2, I am going to add parity bit 2 here. And what is the next bit? 4, I need to add parity bit P3. So I'm going to add all the bits. So what is the message? 1, 0, 1. So this is 1. Parity bit 3 is 1. So now I need to fill up all these bits, parity bits. So P1 is, what are the bits I have? So I am having 1, 3, 5, and 7. So 3 and 5, I have 1 more bits. So if I want to go ahead with the event parity, this should be replaced with the bit 0. It should be replaced with the bit 0. So now what is P2 bit? So 2, 3, I need to check 2 and 3. So it is 1 bit. So I need to replace it with 1 if I get even better. So P4, what I need to do? I need to go ahead with 4, 5, 6, 7. So 5, 6, 7, 1, 0, 1. So I have even bit. So I am going to replace it with G. So this is the general theoretical part that takes place. As far as the parity check is concerned, Hamming code detection or Hamming code error detection and correction. This is the parity check that we have. Now, what I am trying to say is that we are going to see that with some sort of analogy. So let us just go ahead with the synergy of Ramayana. So in the synergy of Ramayana, so Rama needs to send some sort of message to Sita. So let us just consider the message as 1011. So this message Rama should send to Sita so that the message should not be decrypted for anyone. So let us just consider Rama going to send this message with the help of Vanaras. So these Vanaras are nothing but the parities. So he is going to add 3 parities so that the message will not be manipulated or modified by anyone else. So these Vanaras are added. So 3 parities are added to that particular message so that the message will not be decrypted. So regarding the computations and all, we have discussed regarding how we need to replace the parity bits like P1, P2, P3. What are the particular values? We are going to take 1, 3, 5, 7 values at one instance, giving ahead of 1 value for the parity 1. Parity 2, we are taking 2 values like 2, 3. After leaving 4, 5, we are going to take 6, 7. And parity 3, we are going to take 4 values, 4, 5, 6, 7, etc. So like this, we are going to add up all the parities for the particular bits that we are going to transfer. So these parities are going to act as a protective environment for that particular message. So now what happens? So this is the calculation. As I said, 1, 3, 5, 7, we have the value 2. 2, 3, 6, 7, we have the value 3. 4, 5, 6, 7, we have the value 2. So now the final code bit that was sent with the help of the Hanuman. So this is the code bit that was transmitted. So now this particular message, when there is any sort of replacement of 0 or 1, as far as the parity bits are concerned, not the exact message, if the parity bits are changed, then Sita can recognize that there is some sort of error that occurred with the help of this particular message. So now let us just hope 0 is replaced with 1. The parity, the Rakshasas are going to modify the bits as 0 and 1, and the mismatch that occurs while transmitting the particular message. So now let us just see the message that Sita got is 101. So the parity check while transmitting, it is not right, it is not error. So this message should be corrected accordingly. So after checking the parity bits, the message, the true words, that is the particular message 1011, along with this particular parity checks, the message will be detected and corrected by Sita. So this exact entire transmission takes place in the Hamming code error correction step. Hope we have discussed regarding the two concepts. One is the error detection and error correction. So this is the Rama's message and when transmitting the message. So Rakshasa are going to manipulate this particular message. And if the message is manipulated or transmitted, so there are some sort of issues that occur. So this is the entire synergy of Hamming code, error detection and prediction. So hope I have made it clear regarding the error detection and correction strategies. Any questions, queries? Any queries?